Alright, here in this video we're going to cover the 7576 review, which is solving for x within logarithmic equations. Feel free to use the pause button to write some of this stuff down as I go. Logarithms and natural logs help us solve for variable exponents. That's the whole reason we're looking at this. And there's two different solving essentials. One is when your x is in the exponent, you need to do a drop, log, and roll, where this becomes log base 5 of 7 is equal to x, where we dropped the 5 and then rolled the x and the 7. Loop and swoop is when the x is trapped in the log. You take your base, raise it to that power, and set it up equal to the term inside the logarithm. If you don't see bases, they're invisible 10 with logarithms. If you see the base is whatever you see. Ln of x is forever invisible base e. Here are the properties of logarithms. If you have a log and the two terms are multiplying, you can have those two same terms in separate logs separated by addition. If you have two terms in one log via division, you can take those same two terms but use subtraction. If you have a log with an exponent, you can move that exponent out front. Those are the three logarithm properties. Those work as well as if I replaced all of those log of b's with ln, all of those properties would still work the exact same. Now, when we're solving equations, our goal is to set it up so that we can use either loop and swoop or drop, log, and roll. Now, we may have to use regular solving steps first, though, if needed. Here's how you know which ones to use. If x is the exponent, we need to drop it down with drop, log, and roll. If x is in the logarithm, we use loop and swoop to help it escape. You can use the same base method if you want, but you're always allowed to use logarithm method always. Now on all of these, you have to think, where is my x? X on all of these is in the exponent, so we'll be using drop, log, and roll. So for this first one, we have log base 9, 27 is equal to 2x with the drop, log, and roll. Now I would divide both sides by 2 to get my answer here of log base 9 of 27 all over 2. Now, if you type this one in on your calculator correctly and you hit math enter, you will get x is equal to 3/4. And that was one that we could have done with the same base method if I rewrite this same problem as expressing this as 9 would turn into 3 squared with the 2x that's already up there. 27 is 3 cubed, so we have 3 to the 4x is equal to 3 cubed. Set the exponents equal, and we'll get that x is 3/4. But let's keep solving with drop, log, and roll. On this one, before it's ready for drop, log, and roll, I will need to add the 5 to both sides. Now it's ready for drop, log, and roll. Alright, drop the 4 with the log, swap the x and the 17. And this one if you typed it in, remains as a decimal, so we would leave the answer just like that. On this one, before we do drop, log, and roll, I'll divide both sides by 4 to get our base isolated. 10 over 4 can simplify to 5 over 2. Now, since this one is an e, I'll use natural log and roll. So the natural log of 5 over 2 would be equal to Rx. For this final one, we'd have to subtract 5 from both sides first to get a -4. Now when I do natural log and roll, we get natural log of -4 is equal to x plus 6. All right, and then I would subtract 6 from both sides. So I have the natural log of -4. All of that subtract 6 is equal to x. However, on this one, This one ends up being, when you go back and check your answer, extraneous, because you can't take the logarithm or natural log of a negative number. So this one ends up being no solution. And you can verify all these solutions by typing this in on your calculator and then plugging it back in on your calculator as A and S. And when you type it all in correctly and you have the right answer, this side should end up equaling 10. Here are some more I'll continue to do. This one's already ready. For natural log and roll is equal to 2x. I would divide both sides by 2. And here is my answer. This one, before we're ready for drop natural log and roll, I would need to divide both sides by 7. So I have e to the 5x plus 8 power is equal to 0.23 divided by 7. Now when I do the natural log and roll, 0.23 divided by 7 is equal to 5x plus 8. To continue solving here, I'd want to first subtract both sides by 8. So we'd have natural log of 0.23 over 7 subtracted by 8. And then all of that divided by 5. As we subtracted the 8 and divided by 5. And there would be our answer. Now that one looks very complicated, but if you type it in on the calculator correctly, you can still check it with your calculator. Alright, this one here. It's ready for drop, log, and roll. So I've got log base 15. 245 is equal to 2n minus 3. We would then take that log answer. We would add the 3 to both sides. And then we would also divide by that 2 to get that x. The final one, it's ready for drop, log, and roll already. It's equal to n minus 2. Add the 2 to both sides, and there's your answer. Now here in this section here, we're going to solve each equation. Where is x? X is trapped within the logarithm on all of these. We will need to do loop and swoop. If I don't see a base, it's base 10. So this is 10 cubed is equal to 4x plus 2. 10 cubed is 1,000. I would subtract 2 from both sides. I would divide both sides by 4. And we'd end up with 499 divided by 2 is equal to x once we simplified 998 divided by 4. This one's not yet ready for loop and swoop. I'd first have to add 8 onto both sides. Then I'd have to divide both sides by 4 to get that 4 in front gone. Right, and now it's ready for loop and swoop. So 2 to the 11 over 4 power is equal to x. This one, invisible base e. E to the 7th power is equal to 3x minus 4. I'd add the 4 to both sides. I'd divide both sides by the 3. And there's our answer. This one here, I have to add 7 to both sides. I'm ready for the loop and swoop with my base e. And we divide both sides by 2. Be sure as you're trying these, type e to the 11th power divided by 2 in your calculator, and then go back in and make sure that if you type this in on your calculator, using the second answer, that you reach the value of 4. Now these final problems here, we are going to need to do loop and swoop, but we'll first need to do logarithmic properties first. So on this one, I can condense the fact that they're with subtraction into one log using division. Now it's ready for loop and swoop with invisible base 10. So we have 10 cubed is equal to x over 4. 10 cubed is 1,000. Multiply both sides by 4, and you get that x is equal to 4,000. All right, for this one, they're both natural log. It's addition, so this would be x times 4 to give us a 4x is equal to 2. Loop and swoop, e squared is equal to 4x. Divide both sides by 4 to get that x is equal to e squared over 4. In the final one, we've got natural log again. It's with addition, so I can multiply 3x and 2x to get 6x squared. It's equal to 3. So here I've got e to the third power is equal to 6x squared. I will divide both sides by 6. Then I'd have to square root both sides. So remember, when you square root both sides, you will get plus or minus. So we have e to the third divided by 6. Now, what you'll want to recognize on this one, though, is the original problem is not going to accept negative solutions, right? So and they won't accept the negative solutions because you can't take the natural log of a negative number. So when I try to use this negative solution, it won't work. It's extraneous. So our only solution will be the positive square root of e cubed divided by 6.